So Vantika, this is the first numerical volume of a given mass. Now, if you see, there'll be two kind of numericals. So in the first numerical, they will say volume of a given mass of a gas at 0 degrees Celsius is 2 decimeter cube. Calculate the new volume of the gas at constant pressure when the temperature is increased by 10 degrees Celsius. So one thing that we need to understand is that if constant pressure is mentioned, then we know that this is a case of Charles law. Avantika, are we clear?
Yes.
Because in examination, now because we are doing Charles law, so we know that we are doing numericals of Charles law. But in examination, we won't be aware which numerical is this. Now compare this kind of numerical with this kind of numerical. A 20-liter container holds 0.65 mole of helium gas at 36 degrees Celsius. At a pressure of this, what will be the new pressure inside the container if the volume is reduced to 12 liter, temperature is increased to 1.25 mole of additional helium gas was added to it. Now, when they say this, again we have P, V, T, and N. Now, if you see this numerical P, V, T, N, what you will observe is that the number of moles is constant, the pressure is also constant. So only these two are changing because only volume and temperature is increasing, changing. So we'll be applying Charles law. Avatika, have you understood?
Yeah.
But in this case, if you see, this is a case where 20-liter contains 0.65 mole at 37 degrees Celsius at a pressure of 6 to 8.3 bar. Now, this is the state 1, and this state 1 will change to new pressure, reduced to 12 liter. Temperature is increased to 177, and 0.125 1 1.25 mole is additional is added. So 0.65 plus 1.25 mole. Have you understood what I'm trying to say?
Yeah.
So here the state 1 is P1, V1, T1, N1, and the state 2 is P2, V2, T2, N2. So you need to be very clear when you are doing exam, because in an exam they will give you all kind of numericals. So you won't be aware that which law is applicable. So you have to study the numerical very closely. Have you understood what I'm saying?
Yeah.
Then at times you will have to make some assumptions also. For example, if you see D part, hot air balloon has a volume of 2800 at 99 degrees Celsius. What is the volume if the air cools to 80 degrees Celsius? Now, they are not saying anything about the pressure or the number of moles. But because no other information is given, I'll have to assume that Charles law would be applicable here. Have you understood what I've said?
Yeah.
Because कुछ और है ही नहीं, अगर कुछ और है ही नहीं तो मैं फिर कैसे न्यूमेरिकल करूं? Because they are saying nothing about the pressure and
Mm.
number of moles. Because they are saying nothing about it, I'll assume that these two are constant. Have you understood what I've said?
Mm.
See, right now we are doing numericals of Charles law. So we understand that in numerical C, numerical D, numerical E, 0 degrees Celsius, gas occupies 22.4 liter. How much hot gas Celsius Kelvin to reach volume? We understand that the Charles law V1 upon T1 is equal to V2 upon T2. This would be applicable. We understand that this. But when we are sitting in exam, we won't be aware that which law would be applicable. And that is why you will have to, look at the numerical very closely that what are the conditions which are changing. शिवी तुझे समझ आ रहा?
जी.
The second thing that you will always have to keep in mind is whenever you are doing gas law numericals, never do the numerical in terms of just make it a habit that always convert the degree Celsius to Kelvin. Have Have you understood one thing?
Yeah.
This is a very simple thing that you can follow. Never ever do in gas laws. In gas laws, never ever do a numerical in degrees Celsius. Never ever. Always convert it into Kelvin.
Yeah.
See, gas law is a very simple chapter connected to thermodynamics. Thermodynamics at times becomes a bit difficult, but gas laws is very simple. Gas law, people who find gas law difficult are the people who are facing difficulty in the stoichiometry part. जिनको मोल concept समझ नहीं आता उनके लिए gas law थोड़ा सा difficult हो जाता है. Otherwise it is a very simple concept. Okay. Now,
Okay.
after this introduction, let us try to see कि ये this numerical is simple enough. ये all these three numericals are simple enough. The only thing is कि what we need to understand is कन्वर्जन हमें समझ आने चाहिए और कुछ बेसिक चीजें हैं कि वी कांट बी अप्लाइंग टेम्परेचर जो है वो डिग्री सेल्सियस पे हमें नहीं चलाना. तो 0 डिग्री सेल्सियस, so this would be 273 Kelvin, 2 decimeter cube, 2 decimeter cube. This is state 1. Calculate the new volume of pressure if the temperature is increased by. Now, when they say by, you should understand that 0 degrees Celsius would become 10 degrees Celsius, 0 plus 10 degrees Celsius. So 10 degrees Celsius would be 283 Kelvin. And they are asking us the new volume. So V1 upon T1 is equal to V2 upon T2. Avantika, are we clear?
Yes.
So this would be the A part. And in B part, V1 upon T1 would be V2 upon T2. Here it is decreased by 10 degrees Celsius. So rather than basically this would be minus 10 degrees Celsius. And hence it would be 263 Kelvin. Are we clear, Avantika?
Yes, sir.
And when I solve for V2, of course, because on the left hand side, my volume is a decimeter cube. When I solve for V2 in part 1 and V2 in part 2, I will get my volume in decimeter cube. Are we clear?
Yes.
Did you get the right answer?
Yeah.
YCB Tera?
जी.
Okay. The numericals are simple. You won't face any difficulty in the numericals. So if we look at the D part, hot air balloon. So this is our V1. This is our 99 plus 273, 372 Kelvin. What is the volume if the air cools to 80 degree Celsius? So this would be 273 plus 80, 353 Kelvin. So again, V1 upon T1, V1 upon T1. T1 is 372 is equal to V2 upon T2. T2 is 353. And again, my answer would come as a meter cube. Ms. Avantika, did you get the right answer?
Yeah.
Shivang, tera?
जी.
Okay. Let us look at the E part. At 0 degree Celsius. So 273 Kelvin. Gas occupies 22.4 liter. So this is my volume. How much hot must be the gas in Celsius and Kelvin to reach a volume of 25 liters? So again, V1 upon T1. So V1 upon T1 is equal to V2. Now here V2 is given upon T2. This is what is required, and the answer which will come here would be in terms of Kelvin. Why? Because I am taken Kelvin here. So this is all that simple things that you need to take in mind. That so, for example, here the volume is in liters, and on right hand side also it is in liters. But if on left and right hand side, if the volume is say meter cube, on one side it is meter cube, other side it is decimeter cube, then you should know how to convert between meter cube and decimeter cube. So one thing, am I making sense?
Yeah, sir.